Elementarays. All right. In our last lessons, we have been learning how to isolate variables and knowing that there's several steps that we have to take in order to isolate the variable all by itself. Well, today we are going to be building upon those lessons, and we are going to be looking at how do we solve equations when the variables are on both sides. So before, the variable was always on one side, and you just had to say x equals 5 or x equals something, right? We were trying to solve for that. Well, in these equations today, we're going to be looking at how do we solve when it says something like 4x is equal to like 2x, and we have to try to figure out get the variable to one side so that we can isolate. All right, so in our lesson, our whole goal is to get the variables to one side. Sorry about that. My neighbor's alarm was going off. That's craziness. Okay, so our goal, our overall goal so that we can isolate and solve the variable is to collect the variables on one side. Collect all variables to one side. Okay, and then we want the constants on the other. So it might look something like this. Variable equals constant. Okay, so that is our goal right there. That's the goal we want and the goal that we need. Collect all variables to one side and constants on the other. So keep that in your mind as we're working through these different problems here. Okay. All right, example A says, solve 15 minus 2x equals negative 7x, and then it wants us to check our solution. So right now you can see you have the x here and an x here. So we're going to start out by looking for our goal, which is to put the variables on one side. So we're going to first draw a balance line so we can move from one side to the other. Okay, we're still going to keep this idea in our heads around opposite operations, but we need to be thinking about what happens if we do the opposite operation. So if I were to add 7x over here, that gets rid of everything on this side and puts both constants and variables all on the same side, and that's not what we want. So we're going to choose the side that has both things. Okay, so on this side, it says minus 2x. So to get rid of a minus 2x, to zero it out, we're going to add 2 x's. So we're going to add 2 x's to this side. They go away. And on this side, we're going to add 2 x's. So now what we have is a 15, which are the constants. That's a constant. It will always be a 15. And on this side now, we had negative 7, and we've added 2. So that means that we have a positive 5x. No, I'm sorry, a negative 5x. Sorry. I forgot. I thought the negative was there. Okay, so we have a negative 5x because I had negative 7 in the bank. I deposited 2, so now I still owe $5. So owing 5. Now this problem right here looks like a problem that you could do with one step. So you are now going to solve this as a one-step equation. So our first step was to move the variables. Move the variable terms. Okay, so we move this variable to here. Our second step is to solve or to isolate the variable. So let's go ahead and isolate that variable. So we're going to divide by -5 and divide by -5. That gives us 1x. Okay, so now we can say that 15 divided by 5 is 3 with a negative, so it's a -3. So x equals -3. But we have to check. We need to check our solution to see if we moved everything to the right sides and to make sure that our answer makes sense. So if I say that -3 is the solution, I'm going to take this -3 and I'm going to put it into both sides now because it's x, and x equals here and here. So we're going to come back up here and we're going to say 15 minus 2x, and that should be -3, so times -3 is equal to -7 times -3. Okay, now we're ready to check. So we know that 7 times 3 is 21, and they're both negative, so that equals a positive 21. Over here, we're going to start with multiplication. So -2 times a -3 gives me a positive 6. And 15 plus 6 equals 21. So 21 is equal to 21. It checks out. So -3 is the solution to this problem. All right, so now we're going to go ahead and we're going to try a second problem. So we've got our, let's go ahead over here and step 3, check with substitution. All right, so move the variable terms or the constants, whichever. But on this one, we moved the variables. Then we isolated and we checked our solution with substitution. Okay, so the next problem that we want to look at, let's go ahead and do our next one. Our next problem, I'm going to just turn the page now since I'm pretty much out of space. All right, example B. Example B says that R equals -5R plus 18. Okay, so our goal, remember, is to put all of the variables on one side and all of the constants on the other. So now what we're going to do is we're going to balance. And we're going to look to see what can we move. Well, if I move this R over here, I have nothing left on this side. So I don't want to start with that one. Instead, I want to start with this, plus 5R. So if I add 5 here to zero it out, I need to add 5 R's on this side to keep it balanced. Now, I can drop down my 18. This, remember, is like 1R plus 5 R's, which gives me 6 R's. Okay, now we are ready to balance this equation. Okay, so now we're going to balance. I need to isolate, divide by 6, divide by 6, and I get 1r, so r equals 18 divided by 6 is 3. So r equals 3. We're going to now take this and we're going to plug it in to check our solution. So over here I said r is equal to, so instead now I'm going to say 3 is equal to negative 5 times 3 plus 18. Okay, so I also have a 3 equals, okay. Negative 5 times 3 is actually negative 15 plus 18. So I had negative 15 in the bank. I deposited $18, which gives me 3. And 3 is equal to 3. So my solution checks out. Good job. Okay, so let's go ahead and do a try it now. I would like for you to do a try it. And on your try it, get a different green pen. This pen is not working. All right, your try it, it says negative 3x equals 2x plus 20. And then you have another try it, and this try it says 2y plus 6 equals 4y minus 1. All right. So go ahead and hit pause so that you can solve these. And then when you're ready, you come on back. All right, so let's go ahead and solve this problem. I want to get the x's to one side. So instead of positive 2x, I'm going to subtract 2x. So minus 2x. That zeroes out, and I can drop down my 20. And now I have negative 3 minus 2 more, which gives me a negative 5x. And now I can divide by negative 5 and divide by negative 5. X equals negative 4. So let's check our solution to see if we did this right. So x equals negative 4 is what I think. So now I'm going to do negative 3 times negative 4 equals 2 times negative 4 plus 20. So remember, you're substituting this x in for every single x that you see up above. So this is positive 12. It's negative 8 plus 20. I know if I have negative 8 in the bank and I deposit $20, I get 12. And 12 is equal to 12. So my solution checks out. Okay, now let's do this problem. This problem is a little bit different because we have both constants and variables on both sides. I wish they would have given us this as our practice one up above. But that's okay. We can still, this is part of the try-its. This is part of our learning. So we're going to start with moving variables to one side and moving constants to the other. So my first step is to get this variable away from this constant. So I'm going to subtract 2y and subtract 2y. Now this zeroes out, and I have 2y minus 1 equals 6. Okay, now this problem here looks more like something that you're used to. So now that we've got the y's on one side, we need to get rid of this and move that to the other side. So we're going to add 1, and we're going to add 1 to this side. This gives us 7 equals 2y. Now we have a one-step equation. So we're going to divide by 2 and divide by 2. This tells me that y is equal to 2, 4, 6, plus 1 left over, so 3 and a half. Now I can take my 3 and a half and I can plug it in to this problem up above to check my work. So if I have 2 over 1 times 7 over 2 plus 6. So, and we want it to be 4 over 1 times 7 over 2 minus 1. Ooh, I should have used a different color. Okay, so here's our x. Here is our x right here. Our y, we're just plugging it into this equation. 2 times 7 is 14 over 2 plus 6. And what's this one? 4 times 7 over 2 minus 1. Okay, so 14 divided by 2 is 7 plus 6, and that equals 13. And this is 14 minus 1, which is 13. And 13 is equal to 13. And so our solution checks out. If you are starting to lose track of your numbers, grab a sticky note or another piece of paper and just start to break it up one part at a time. Start on one side, then move to the other side so that you're not losing track. If you're done solving all of this and you want to check your work, just start with a new fresh problem down below. That way you're not getting confused with all of the numbers. So little tricks to help you along the way, because this is a lot of math that you're doing now. And so we don't want you to lose track of the work that you are doing. Okay, so now I would like for you to please answer your essential question. Okay, our essential question was, how do we solve equations when the variable is on both sides? How do we do it? What steps do we have to take? What's something important that someone who comes along would need to know? Go ahead and answer that here. And then put your rating out of 3 out to the side. Where are you with your understanding? 1, I don't know, Miss Englander. I got to go back and look at the videos from last week. Or maybe something else. 2, you're getting the hang of it. This number 2 example threw you off, and so you need some more practice with those ones. Or a 3, I understand. I'm just moving things from one side to the other and back and solving for a variable again. All right, Manta Rays. I hope that today's lesson was a good one for you. And I hope that you are able to follow along. If not, please come to the Google Meet and ask for help. Otherwise, make it a great day the Manta Ray way.